In previous classes, I was describing how to do deletion in queue when it is represented as one-dimensional array. So how to write a C program for deletion operation, which is done by a function del q, and what are the parameters to be passed to this function so that it will delete the front node of a queue when the queue is represented as an one-dimensional array. Thoroughly, I described every step of deletion, and considering the all possible cases for deletion, and we implement that C code onto machine. So deletion operation has been implemented successfully after giving a thorough explanation how deletion operation is being done on a simple queue when it is represented using array. So in this video we will discuss about the insertion operation into a simple queue when the queue is represented as an one-dimensional array. First, we will see the cases for insertion operation, and when this different cases occurs, then how insertion operation to be handled, and what will be the C code for insertion operation that we will write after getting explanation how insertion is being done. Then we will implement that insertion onto machine, and whatever insertion C code we will write here, that will be implemented onto machine. So the insertion operation is like that. Maybe it may be different. What may be the operation? Maybe it's deletion operation, or it may be the insertion operation. Everything is done within a function which is defined by the user, that is by us, by the programmer. Now already we know that in queue, insertion and deletion occurs at a particular place of that queue. We know that deletion occurs always at the front end of the queue, and the insertion occurs always at the rear end of the queue. Where the insertion new item to be inserted into the queue, and where the item to be deleted from the queue, that position is always fixed in case of queue. So that is the difference with the linked list. In linked list, insertion, deletion can happen at any places of the linked list, but in queue, insertion and deletion are to be done at a particular position at a particular end of the queue. So first of all, we will remember that insertion is done only at rear end. That means the last end of the queue. Insertion is done at rear end of the queue. Insertion is done at rear end of the queue. So what will be the cases why we are doing the insertion operation? What are the cases we have to handle? That we will see first. So in case of insertion, maybe that queue is already full. So in that case, the new item cannot be inserted because it has no vacant space. So in that case, when the queue is full, then while trying to insert more items, then a proper message will be given to the user that queue is full, so new item cannot be inserted. So number one case is that when queue is full, then the insertion operation will not be done, and instead of that, a proper message will be displayed that the queue is full. Number two is when the queue is not full. Case 2, when queue is not full and when queue is not full and not empty. So in my lecture, and the third case is that when the queue is empty. When queue is empty. So these three cases we have to handle. These three cases we have to handle, or these three cases are to be considered while we are doing insertion into queue. So actually here I want to say one thing. While I can write the program directly to the machine, but what I think before writing it to machine, the theoretical explanation should be clear, so that while we can write the program for insertion function, write the function for insertion, so there will be no misconcept or misunderstanding that why this code is being written. That's why always I try before implementing it machine, the code should be theoretically explained how this code is being written, based on which conditions, then that will be implemented on the machine. So that is the why I'm giving a description here thoroughly using pen and paper. And when this basic work has been done, after writing it on pen or paper with thorough explanation, then I try to implement it onto machine so that to check whether my code is working properly. Okay, now what we have explained that queue is full, but how to know when the queue is full? Always this is in this example we are using the queue, which is represented in memory as an one-dimensional array. Suppose the array which represents the queue can accommodate only 5 elements. So if I draw the diagram of that queue in terms of array, 0th index, 1, 2, 3, 4, so that it can accommodate only 5 elements in the queue. So what is the array size? Suppose array size is a constant that we will declare, and the size of the maximum size of the array equals to array size minus 1, where array size equals to 5. So this is the array, and so we will consider first case when queue is full. So all of the positions in this array are filled up by some item. Suppose 0th index, their item is 10, then 20,